Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com program, brought to you by Techstrong and Fairwinds. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation ahead. First, I do have just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, or maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we'd like you to send those in to us using the Q&A tab. You can find that tab on the right side of your screen with a few more options. That's where you'll also find the chat tab, and we want you to use that one just for getting to know your fellow audience members, letting us know where you're from, or maybe what role you play in your company. We do have 2 polls that we will load up throughout today's program, so we really do want your participation there. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of today's program. So our topic of discussion today is AWS Karpenter Readiness. Are your apps ready to move? I'm joined today by Andy Suderman, CTO at Fairwinds, and John Hashem, Senior Solutions Architect at Fairwinds. So Andy, John, thank you both so much for joining me once again. Andy, do you want to take it from here?
Thank you, Cody. Appreciate it. So as Cody said, I'm Andy. I'm the CTO at Fairwinds. I've been a longtime Kubernetes user, longtime employee at Fairwinds here. We got our start running clusters years ago, and now we're doing software. And I'll let John introduce himself real quick before we move on.
Hey, everyone. John Hashem, Senior Solution Architect over here at Fairwinds. So my job at Fairwinds is to help customers accelerate their journey on Kubernetes. So thank you for joining today.
Thank you, John. All right. So who is Fairwinds? Fairwinds is the trusted partner for Kubernetes security, policy, and governance. With Fairwinds, customers ship cloud-native applications faster, more cost-effectively, and with less risk. We provide a unified view between dev, sec, and ops, removing friction between those teams with software that simplifies complexity. What that really means is we know Kubernetes, we've been using it a long time, and we know all the ways that you can break it, and we're trying to help you not break it. So we'll kick this off real quick with a polling question. Where are you in your Kubernetes journey? So a few options here. I'm just learning about containers in Kubernetes, planning to use it in 6 to 12 months, using only in a test dev environment, or using it in production. So I will answer with using it in production. But please answer the polling question, and we'll get some results here in a second. John, where are you in your Kubernetes journey?
Oh, I don't know, Andy. That's a tough one.
I'm never sure whether I'm supposed to answer the question or not, because it gives me the option. All right, we've got some results here. So it looks like we've got about half the folks here using it in production, 33% just learning. Quite the split on either end there. And then some folks using it in a test dev environment. Nobody's planning, so everybody here is already using it in some way, or they're very early on in the journey. So that's great. We're going to give good advice for all of you here today, I think. So, all right, let's move on to what is Karpenter. I think John's going to tell us a little bit about what Karpenter is and what it can do for us.
All right, thanks, Andy. So we're going to start off with Karpenter. Obviously, a big talk today that is very relevant in the Kubernetes community. And what it really means to folks is that when you think about Kubernetes, it has a lot of kind of dials and knobs to add either to scale or to perform a little bit better. And what I mean by that is Karpenter is a cluster autoscaler. And really what that means is when you have workloads that are ready to be scheduled on new nodes, if there's not any available, Kubernetes can kind of raise its hand and say, hey, we need some more. And that's where, the cluster autoscaler really comes into play.
Right.
And, Karpenter's, go ahead.
Can I ask, there is the cluster autoscaler that we've used forever now, since way back in Kubernetes. What makes Karpenter better than that, or why not use cluster autoscaler instead of Karpenter?
Yeah, so since they both have the same or very similar kind of constructs of adding new nodes when capacity is needed, the kind of promise of Carpenter is flexibility, and also cost efficiency. So when you think of like cluster autoscaler, it relies on some kind of operator decisioning, right? When you work with it, you're like, all right, I need this type of capacity here, or these type of instance sizes or flavors that I need to provision on. But that's it's difficult. It's not easy. You don't really know, and it requires a lot of kind of time and effort to do so. And that's kind of where Carpenter can make that easier for you.
Gotcha. So would you say Carpenter's like take the smarter version of cluster autoscaler, kind of takes a little bit of the guesswork out of using cluster autoscaler?
Yeah, it's kind of the things that I think users want out of the cluster autoscaler is they're like, help me, provision the best nodes for my environment,
Right.
make them, cost efficient, and when just make that whole process easier for me. It's a really tricky process to manage and can really be super complex when you start to put in things like, how do we make this decision efficient for my organization?
Gotcha. Awesome. Well, cool. I think we should just jump into the demo. What do you think?
Yeah, I think this is great. I think Andy's going to walk us through a pretty cool demo today. So excited for you all to see this.
All right. So as John said, Carpenter is an autoscaler. It's going to provision nodes for us. And it works via these objects called provisioners. So if we look here, we have a provisioner in the cluster called default that we have created ahead of time. And if we take a look at that in our cluster, we're going to see some configuration information about like instance profiles and security groups and things to do with the EKS cluster that we have this attached to. And then we're going to see some requirements. And so basically these are requirements for the nodes that are coming up. We're saying we want to be able to provision these kind of nodes across our clusters. So we have spot specified here as our capacity type. So we're only going to ask for spot instances. We can ask for a mix of on-demand and spot. And then we have a list of sort of allowed instance types. Now, if you don't set this, it literally will pick from any instance type in the whole AWS cloud, which is cool and also vaguely terrifying. And then here we have specified AMD 64 nodes only for architecture. And then this is the interesting setting. We have consolidation enabled true. This is a newer feature of Carpenter that will allow Carpenter to sort of shuffle things around and consolidate down to less nodes if it sees an opportunity to create a better node configuration for either price or number of nodes or things like that. So you may think, this is kind of dangerous, right? We're just getting rid of nodes all the time. And so today we're going to talk a little bit about how that's dangerous, what it allows us to do, and how we might go about using one of Fairwinds' open source tools, Polaris, to avoid some of these dangers. All right. So the first thing with that consolidation feature, we want the ability for Carpenter to make nodes go away, right? So if I take a look, we have two demo apps running in this cluster. I forgot to talk about this. So we have two apps running in this cluster. We have this example voting app where you can vote for where to go lunch, and it keeps it in a database. It's a multi-tiered app. And then we have this demo app, which basically just pings and shows you which pods it's talking to. So we see we've got 300 containers, 300 pods in this demo namespace that we've been hitting. And so I'm going to go ahead and scale that down by modifying my horizontal pod autoscaler. Turn the min down to 3 here. And I'm going to apply that demo app again. And so we're going to have a lot less pods in this cluster all of a sudden. All right.
This is the fun part.
Yeah. So, and then I'm actually going to The Yelp app has 3 components, got a UI, an app server, and a DB. And I believe we have scaled the app server up. So we're just going to cause a little bit of churn in this cluster, bunch of node churn. All right, we'll reapply that as well. So hopefully we start to see some nodes move around and things like that. So the first danger we're going to talk about while this kind of scales up and down is that Carpenter gives you a lot of options that you can set via annotations and node selectors and things like that. The first one that's sort of interesting is that, we talked about the danger of nodes coming up and down quickly. You may have apps that you're tempted to put an annotation on them to not evict them from a node. Like you're worried that it's going to crash if you lose pods, right? We need to be resilient to that, but sometimes we're not. And we may be tempted to use the carpenter.sh/do not evict annotation. And that's probably something that we shouldn't be using. If we want Carpenter to be able to consolidate our pods, we probably shouldn't do that. And so this is where something like Polaris could come in that's Fairwinds open source tool for doing policy, where we could write a custom check to not allow that annotation. So I actually have that set up here. So we have Polaris running in this cluster already. And if we look at our configuration for Polaris that's in here, we'll see I have a couple of Carpenter checks in here. And I have this disallow Carpenter block. And so I'll make this full screen here. We have this custom policy that looks at the pod template, and it looks for the annotation, Carpenter do not evict, and we want to make sure that's not set to true. So if we go over here and take a look at our Polaris dashboard, we've got our 2 demo applications, Yelp and demo. And if we take a look, we will see here we have a failing check that says, please set carpenter.sh do not evict annotation to false. And so we could use we can surface this in the dashboard. We can make it a warning, or we can even use the validating admission webhook in Polaris to prevent deploying that into a cluster.
So you're saying, Andy, with this deployment, since this is this annotation is key or something that I want to check, I could have some type of behavior where I could introduce blocking behavior to say, like, do not let this get created if this thing is missing or what have you. Is that a good way to think about it?
Yeah, exactly. Like if somebody tries to create a deployment with this annotation, we say, nope, can't do that. All right. We are not seeing the node churn that I was hoping for. All right. That's scaled down.
And the interesting thing too, why Andy is pulling this up, is that Carpenter has an understanding of the price lists within your cloud provider. In this case, it's AWS only. So it's very interesting to know that, hey, there's scheduling decisions that has a price context into the decisioning. So that's pretty neat.
Yeah, definitely super cool. Super cool. So hopefully what we'll see, I just scaled the Yelp app down to 3 pods. So if we look in the Yelp namespace, what we should be seeing is a bunch of terminating pods. And I scaled that way down in the hope that Carpenter will start to consolidate this cluster. So we're going to have a lot more capacity in this cluster than we really need. We can look at use another tool here written by an old coworker of mine, Rob Scott, called Cube Capacity, which will show us right now our CPU requests are 99% of our nodes. Hopefully that goes down as we start to see less copies of the app running. This is the danger of a live demo involving auto-scaling. You kind of have to hope that it works. All right, so down to 3 there, down to 3 there. So what we should see, if this works the way it's supposed to, is that Carpenter's going to notice that we have too many nodes, and it's going to start evicting pods to try to move them off of a specific node that it determines we don't need anymore. And because we have that do not evict true annotation set, we can take a look in the Yelp app at the deployment. I think the DB has this annotation, Carpenter.sh do not evict. It's going to block Carpenter from scaling down that node. And so we're just going to sit here at this node count with a node that is actually tainted from being scheduled on for an indefinite period of time while we wait for either the sanitation to be removed or for that pod to go away or something like that. So first use case, maybe we just don't let people do that. Polaris lets us set exemptions if we feel like it. So we can definitely, use the annotation in places that it's super important. But in general, we don't want to see that. So I'm going to go ahead and remove that from at least one of the deployments. And we'll go double check in our Polaris UI and make sure that the DB doesn't have that failing check anymore. And it does not. Pod template does not have the Carpenter SH do not evict true annotation. So that's our first big gotcha that we might have using Carpenter. The second one is another feature of Carpenter. I mentioned node selectors. So if we take a look at our lovely demo app here, we have the ability to say, hey, I only want to use this node type for this application, which may sound like a nice feature, right? Like maybe I think I need a C5A for XL specifically. But what that's going to do is it's going to sort of modify the topology of our cluster. So if I have multiple apps running in this cluster and one app says I want C5A4XLs and the other app says I want C5-4XLs, well, now Carpenter has to spin up both. And we'll see I just applied that. Here's our demo finally happening for the do not evict.
There we go.
We'll see that if we describe that particular node that says scheduling disabled, we'll probably see some Yelp pods on that node that are unable to be removed. All right. So if we describe that and we scroll up to the pods list on here, maybe I'm missing it.
Yeah, just think about too with the days of the cluster autoscaler. If you had a workload that needs GPU or something that you might not have thought about that is being introduced into your environment, that requires a lot of overhead to create that new node group and kind of have that kind of framework in place. Where Carpenter is like, I got this. Let's do it. So that can really help with kind of the administrative overhead here. Obviously, with what we're showing you today, and is a whiz here, so that's probably not the usual, but just something to be aware of.
Yeah, definitely. Much easier to, like this is a nice feature. I just asked for a C5A4XL. I got a C5A4XL. Now, if I do that across 10 different teams, that may be a problem. And that's where your provisioner comes in handy, right? You can restrict the number of node types that you want to allow, but also we can use Polaris to disallow specific node type selection. So node type, if we take a look at this, we're going to look for the node selector and we're going to say not the node.kubernetes.io instance type. And now that we've applied that to our demo app, we can actually refresh here and see that we're going to be failing that check. So it says here, please remove the node instance type node selector. So you can see here, actually, we have our C5A4XL, and Carpenter has actually scaled out a different node, removed another node to handle that. So that's kind of the second thing you may want to consider using Polaris to disable if you're looking to use Carpenter. And to John's point, I actually wanted to show something else off here. ARM nodes are becoming kind of a popular thing, right? And so maybe I want to mix some into my cluster. And Carpenter enables us to do that really easily. So I created this other provisioner. It's called ARM64 that will spin up some ARM-based nodes. I believe you can actually mix this in with the other provisioner. I don't think you have to do it as two separate ones, but in any case, I did it separately. And what I'm going to do, I know Polaris has recently added ARM support. So I'm going to go ahead and add the node selector, Kubernetes.io/arch ARM64. So I'm doing that for both the webhook and the dashboard pods and the Polaris deployment. And so we're going to just say, give me an ARM node. And let's go ahead and I'll use the helm command to reinstall Polaris using that values file. So it's just a helm upgrade -- install Fairwinds stable Polaris. And so that's going to immediately start asking for an ARM node. So if we get pods in the Polaris namespace, we'll see that it's pending because we don't have any ARM nodes available. And we'll see here that 0 nodes are available that match the node selector. So here in a few seconds, Carpenter's doing its job. We should see an ARM node just pop up to handle that for us. So another great feature and lots of flexibility that you get from Carpenter here.
Yeah, and one interesting thing too as well that I was doing some research is, when you think about cloud commitment models of your hedging a bet with the cloud provider, to say like, I'm going to use a lot of M5 instance families, and that's what I want to reserve or buy a savings plan. It's a 1 or 3 year commitment. So you want to make sure that all of those dollars that you're leveraging on a commitment model are being used. So that's another way to make sure that whatever the operations team is making their bet on as an organization, that you're actually using some of these scheduling constraints there. It's super flexible. It supports less than or greater than operators. It's a lot of it's Kubernetes native, so it makes it a lot easier for users to define exactly what they wish for, and that's to save money and make their cluster efficient.
Yeah, great point. Along those lines too, one thing Carpenter lets you do is set limits on things. So like if you don't want your cluster to be able to run away from you, you set limits, but you don't set limits on instance counts, right? Because that doesn't really make a lot of sense. You set limits on CPU counts and memory quantity as a whole. So you can kind of cap that cluster at a maximum. So it's never going to cost more than this roughly, which I think is kind of cool. So, all right. So we have our ARM node. It's slowly getting ready here. But we can see that mixed in here. We've got that Kubernetes.io/arch and an A1 medium. So super cool.
Awesome.
All right. Well, let's talk about the next most important thing, I think. And actually, I'm surprised I didn't put this first because this is like the thing I talk about all the time. If you watch any of my stuff and you've seen some of the other webinars I've done, setting your resource requests and limits. You want Carpenter to be able to be efficient, like John was talking about, and build your cluster with the right mix of nodes and things like that. But we're still relying on the underlying mechanisms of Kubernetes scheduling to do that, and that is resource requests and limits. And so that's actually by default built into Polaris to say you need resource requests and limits. And so we see here we're passing that check on our demo app, but if we go look at like our Yelp something, one of these doesn't have resource requests and limits set. The Yelp DB has no CPU requests and no memory requests, and those are now marked as danger. So
I actually know of a tool that might help out with that, to make those just a little bit easier. And I actually know the person who created it, and he's actually here today. His name's Andy, and we're going to talk about Goldilocks. So Andy, you could probably do a much better job than I can explaining it. If you just want to get a quick 1-2 on what Goldilocks can solve for, I think this will be kind of an exciting ad for the talk.
Yeah, definitely. So Goldilocks is a tool that provides a base level of resource requests and limit recommendations. So it uses the vertical pod autoscaler's recommendation engine to look at the usage of your pods and tell you, hey, this is what you should set your resource requests and limits to. It's a great way to get started if you're not sure what to set them to. If you're not setting them at all, and then run over time and kind of reevaluate on a regular basis what you're setting your resource requests and limits to. So another great open source project there. I'm a little biased because I did write it, and still one of the maintainers of it, but Goldilocks is definitely helpful there. So
awesome. Thanks, Andy. Yeah, we actually have a question. What is Polaris? I'm not sure how well that one is here, but we can definitely cover that again. So Polaris is a open source tool from Fairwinds. So we're very big into open source, as you can probably tell. And it's a collection of, best practices that are kind of tried and true that we found to make customers successful in their Kubernetes journey. And a lot of them are relevant here today when you're thinking about, scaling and also things like reliability. And
awesome.
feel free to definitely check it out.
Yeah, I dropped a link to the documentation for Polaris into the chat there. So if y'all want to take a look at that, and then it's on GitHub at github.com/fairwindsops/Polaris. But basically, like John said, it's a tool for checking reliability. Here we're using its custom policy abilities to set up checks for Carpenter readiness. So, our goal is to get all of these checks passing so that we know we're ready to use Carpenter. We want this Carpenter section that I've created via custom policy to be all blue and not red. And in fact, we want all of these to be blue, right? So cool.
And I think there's actually one point we should probably touch upon if you're going to beat me to it is, we're looking at all these churning nodes, right? Of just, all these ones are coming online and going away and, getting potentially, re-added, based on, let's say, a new cost. If you have consolidation enabled, that can introduce some interesting behavior in your applications. They might not be really flexible and having the rug pulled out from them quite often. So that's something that, and if you want to, I don't know, give a little bit more depth on something like a pod disruption budget, I think that could be a good best practice here. We should definitely.
Yeah, definitely. Pod disruption budgets are super important, right? Carpenter's going to respect your pod disruption budgets when it goes to scale nodes down, when it goes to evict pods. And so if you don't have pod disruption budgets for all of your apps, you're going to run into potential scenarios where you're losing a large number of your pods. Maybe your service can't handle the level of just standard level of traffic with that number of pods removed. So you definitely want to be aware of those. And that's another thing that Polaris helps with. We may have seen that already a couple times in a few of these, but one of the default checks in Polaris is that a pod disruption budget is attached to your deployments. And so we can take a look at the demo app, and we can take a look at the pod disruption budget for it. This is a very simple one. We're just giving a straight max unavailable of 1. So we only ever want to have 1 pod removed at any given time out of the desired number of pods. But these can be percentage based. They can be, there's a lot more interesting settings you could do for pod disruption budgets, but make sure you're setting those, make sure you're aware of those. You can even, expand the check to say, only have pod disruption budgets for, that are percentages, not hard numbers, right? Because, if you're scaling an app from 10 to 200 pods, max unavailable of 2 is not really reasonable necessarily, right? Depending on whether you're at 2 or 200 pods. So percentage base is probably better. You could definitely write a custom Polaris check to check for that. But, bare minimum, make sure you've got those pod disruption budgets. I think actually if we go look here, our Redis server doesn't have one. So if for some reason all of our Redis server pods were on nodes that were being scaled down by Carpenter, there's a chance that Carpenter could inadvertently just take out the Redis server for this app for a time, while those pods come back up on other nodes. So we definitely want to have those in place. It's kind of a standard best practice for all Kubernetes clusters, but when you're introducing node churn in the form of, a slightly more aggressive or more intelligent autoscaler that can consolidate and expand quickly, you definitely have to have that on lock.
Cool. Thanks, Andy.
Yeah, definitely. So, on those same lines, there's other things you have to worry about when you're scaling pods up and down a lot, right? Maybe, your pod is serving traffic, quite possibly. I would assume you have at least some serving traffic. So, here we have our voting app. And actually, it looks like our DB restarted because our count went away here and it's not persistent. But anyway, we don't want to route traffic to pods that aren't ready to receive traffic, right? So like, pod has to start up and then maybe connect to a database, do a couple things before it's ready to serve traffic. That's where your probes come in handy, right? You're going to need those liveness and readiness probes in place for to be resilient through node churn like this. And so that's where we, again, back to Polaris, we have by default a check that says you need liveness and readiness probes. So these are right now set to warning. You can configure that level in the Polaris configuration, but we automatically recommend that you set those. So another great check to pay attention to.
Yeah, kind of think of it like when you go over a family member's house for dinner, instead of just walking right in, calling in the driveway, right? They want to be ready for you. You don't want to walk in and, dinner's not ready, dogs running out the door, they're ready for dinner. So that's the way I like to think of it.
No, that's great. I have family members that just walk through the door, like that don't even knock, and it just baffles me. So yeah, they need to get some readiness probes in their life.
Exactly.
Yeah, that's great. That's great. Awesome. Another kind of cool capability that we have in Polaris that I didn't talk about when we were talking about setting resource requests and limits is that you can actually write policy to require a specific range of resource requests and limits. So maybe you want to, prevent deployments, over like 2 gigs of memory, right? Because that's a lot of memory unless you're running Java. That's generally a lot of memory for a small pod, right? And so maybe you want to do that. So we can take a look at our Polaris values here and take a look at another custom check that we've written in here called resource limits. And I believe that there's an example of this in the documentation, but we've made it really easy to do this by extending the JSON schema that we're writing these checks in. And so we have resource minimum, resource maximum on memory here. So 100 megabytes up to 1 gigabyte. And then also on CPU, we're going to say 100 millicores up to 2 cores. So if anything's outside of that range, we're going to generate, a Polaris action item or a Polaris alert that you can block on again with the admission controller. So another kind of furthering the recommendations from Polaris to set the resource request limits. Now you can set limits on them in either direction. And there's definitely a Kubernetes native way to do that. But if you're writing all of your policy in one place with Polaris, it's nice to be able to just put that here. So, all right. Let's do this. Let's scale way up. See what this thing does. Apply the demo. All right, so I'm going to modify the minimums on all of my HPAs, my horizontal pod autoscalers. Appser, set that minimum to 300. And we'll just take a look at Carpenter adding nodes. And then hopefully we'll start to see as it figures out where things need to go. We'll take a look at this consolidation feature as well. We can go ahead and put the ARM64 Polaris nodes back to AMD 64 because why run just one app on ARM when all the others are running on AMD? So We'll go ahead and put that back on an AMD 64 node, and we'll see what Carpenter does with this. We have any more questions coming in, John? I know, folks, please use the Q&A feature if you're not using it already. Any questions in there?
Trying to keep my eye on it.
All right. All righty. Okay. So now what we've done, we've moved Polaris off of ARM. We've said, put me on an AMD 64 node. So what we should see, if we look at the pods in the Polaris namespace, they should have all restarted, or they're pending because we're waiting for new nodes to come up because we just hammered this cluster with pods. But once that cycle's over, that particular node with the particular ARM node that we have running in the cluster won't have anything running on it except for control plane components, right? Except for daemon sets and control plane components. So what we ideally should see is that Carpenter will just take that node out because we're not using it anymore. Nothing's requesting ARM nodes. We have consolidation enabled, and hopefully we'll see that go away. And one other, actually, I always forget to mention this feature because it's like ingrained in my head now, but one of my favorite things about Carpenter, you can make nodes expire. So like I have said here, no node should last more than, is that a week? Or is that a month? I don't remember. Anyway.
Terrible with those.
Yeah, 86,000 seconds, whatever that comes out to. Anybody good at math? Really quick in their head. But anyway, what this does is it says, don't let nodes get old, which is great, especially if you're, like doing cluster upgrades and you want to upgrade the control plane, update your launch templates, and then just wait for the cluster to upgrade itself as all of the nodes expire out. And you can set those short, you can set those long. And Carpenter will actually pay attention to those when consolidating as well. It actually looks at how long the nodes have to live. And the ones with the shortest time to live left, it will scale those out first. So it's super smart about that, which is super cool.
And we got the answer in the chat. Someone says it's 1 day. So
1 day, perfect. So these nodes aren't going to live long at all.
Yeah, if you have 86,000 seconds to live, it's not good.
Thanks. Thank goodness I'm not a node. All right. Hopefully we'll start to see that some of these nodes come up. But any other questions come in? Anybody else?
No, I think we're pretty good. Just waiting for the nodes. I think something we could obviously chat about is looked at Polaris and all the best practices that would be extremely helpful for kind of production readiness, or in this case Carpenter readiness. How would we kind of view this at scale? You have some things that I hear in the field, or customers, they have a lot of clusters that they're managing, or in this case teams are spinning up new clusters for new projects or applications, or even in getting started in Kubernetes, like in kind of dev or test environments. How do you kind of get this information into a singular view, or how can you make this easier for folks?
Yeah, great question. The Polaris dashboard is one cluster, right? And then we have the CLI as well, where we can do a Polaris audit, and that will audit our cluster with all of those Polaris checks that we saw. You can pass the same config into both, but that's still limited to one cluster. So if you have a fleet of clusters, or you've got 3 or 4 clusters, most people have at least 2, right? One non-prod, one prod. I hope you have that. But if you want to expand beyond that, and then you want to incorporate more open source, there's definitely the Fairwinds Insights SaaS platform. So this is our SaaS product that we offer. And this allows you to plug in a whole bunch of open source, including Polaris, including Goldilocks, which we talked about earlier, into one centralized dashboard. So we kind of normalize everything into what we call action items. And so we have a whole bunch of different reports here. We've got Polaris, we've got Trivy, we've got Goldilocks, we've got Pluto, we've got Polaris, all coming into one place, and they all create these similar action items. In addition to that, we give you the ability to do things with those action items. So we have automation rules that allow you to route those action items to different places. So if you want to create a Jira ticket or send it to Slack when it happens. And then we also allow you to push that even further left into your CI/CD process. So now we can hook these Polaris checks that we were just looking at up to your CI/CD and say, hey, this YAML won't be accepted by the system. So we don't have to wait till we get to the admission controller. We can just do that in CI/CD. So it just takes all that great functionality we have in the open source Polaris and allows us to do a lot more with it and to act on it more and see it across a lot of different environments. So that's what Insights does for us. And then we're going to bring in that cost data and that efficiency data. So we're going to start to see across all of our clusters here, like, how much capacity do I have? How much of it am I actually using? How much of it is requests? How much of it is limits? And we can start to see a breakdown of those clusters and their efficiency and start to try and up our efficiency numbers, which helps our cost. And then we're going to correlate that directly to cost by integrating with your AWS billing report. So cool.
Thanks, Andy.
Yeah. Looks like we have a couple more nodes. We haven't lost our ARM node yet, but
Oh, that's interesting.
yeah. Dangers of a live demo. Still pending. Wonder if I
Is it maybe sticking around for a day?
shouldn't, but let's see. Debug. We'll take a look at the Carpenter logs here and see if maybe we can do a little live troubleshooting. All right.
There we go. If anyone has any questions about, Carpenter and some of the things here today, we'd love to kind of answer those for you.
Yeah. I don't know what's going on. We may just have to wait, or I may have misconfigured something in the process here. So definitely a lot of knobs to tweak, and adding Carpenter adds more knobs, which is great, but also leads to potentially more complexity. So make sure you're using some sort of policy or governance, preferably by Fairwinds, to make sure that you're setting all those knobs correctly. All right. I think we have one more polling question for y'all. Got a couple. All right. Last polling question. What is your greatest opportunity to improve your Kubernetes environment? Is it getting help with the basics, a general best practices assessment, improving the security posture of your clusters, saving money, or improving the reliability of apps running in Kubernetes? I would say,
Topics.
yeah, these days for us, it's cost. We've got a lot of focus internally on how we reduce the cost of running this SaaS platform we were talking about, and how do we keep track of it too, and understand what's costing us what and where, and using the Insights platform to do that. So that's been really an interesting exploration that we've had lately.
Yeah, for sure. I think in the times we're in, and Kubernetes is, you get the cost of a node, but then all these things are running in the node. So you're like, what is the cost of this deployment or certain application? That's really tricky.
Yeah, it is definitely. Hopefully we can solve it. All right. Oh, all over the board.
Oh wow.
45% improving reliability. All right. Then you're in a good place, because Carpenter can help you with that. Only if you set all those other things we talked about, PDBs and the resource requests and limits and your liveness and readiness probes. All of these things are super important to reliability. In fact, I didn't really show it, but Polaris divides by default all the default checks into 3 categories: efficiency, reliability, and security. So we've got 18% on saving money and general best practices assessment, and 9% on help with the basics and improving security posture. All right. Thank you, Cody. Do we have any new questions? Anything anybody wants answered?
Nothing new, but I mean, just to go back to Carpenter is only as good as the information you tell it. So the more information, one, you can give it, and two, the less constraints that you provide. If you're really prescriptive on what you can't schedule, like if you want Spot, but if you give it like no instance types, it's gonna have a little bit of trouble there. So
right,
flexibility is key, but also information is helpful when you think about scheduling.
Definitely. Like saying I need an ARM node or I don't need an ARM node, right? You've got to be able to give it that information. So you got to use those, and then also tweak all the levers correctly in Carpenter. Spot's a great example that you just gave. You say I want Spot, and I want only C512XLs. It's like, well, maybe the market's exhausted on that, or whatever it is. So something to pay attention to for sure.
It'd be like going out to a restaurant and the menu's your instance types, but you don't eat meat or vegetables or chicken, or makes it really tricky to get a meal. So that's kind of what I'm here.
John's on point with the metaphors today. I love it.
I'm trying.
Love it. Great. Well, we're going to wrap up here in just a second. We do have a white paper that we're going to share with you all. I believe it is in the handouts of this webinar, but you can also get it by going to the Fairwinds website to get it. So this is Kubernetes, the good, the bad, and the misconfigured. So how to eliminate misconfigurations. Those of you who answered the polling question saying you were looking for reliability, that's definitely going to be addressed in here as one of the key things that we're going to address with misconfigurations. So with that, I just want to thank everyone for attending, and I'm going to hand it back to Cody to wrap things up.
All right. Well, we do have a couple minutes, so I will just encourage our audience to send in any questions you might have in the meantime. So a quick reminder that this session was recorded. So following this program, you'll receive an email with a link to access the recording on demand, or you can find the recording living on the Container Journal website at containerjournal.com/webinars. And like Andy said, that white paper link, it is available in the handout. So do please download that while you can. And so on to our 4 $25 Amazon gift cards. Our 4 winners are Ranjan K, Shur M, Vikram R, and Sanjay N. So to our 4 winners, congratulations. Keep an eye on your email inbox to claim that gift card. But if you don't happen to see that email, do check your spam folder. All right, seeing no more questions, I would like to thank Andy and John for joining us today. I'd like to thank Fairwinds for sponsoring today's program. They're always frequent flyers on the show, and we love having them on here with us. So to our audience, we do have a survey that should pop up on your screen as soon as we close out. We'd really like your participation there. So as soon as we close out, do please fill that out. Otherwise, Andy, John, do you guys have anything you'd like to leave our audience with before we close?
No, thanks for having us. Always a pleasure to be on.
Yeah, thanks everyone. Appreciate it. This is great.
Perfect. Well, thank you both so much. And to our audience, thank you for joining us. We do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day, everyone.